2, it says a shot put throw can be modeled using the equation, where x is the distance traveled in feet and y is the height, which is also in feet. Notice that the shot put will hit the ground. This just isn't illustrated in the graph. So based on the illustration, what would be an appropriate window setting to use? So we need to graph this in our calculator. And to do this, we need an appropriate window setting. So kind of look at the graph itself and think about what's happening when you're throwing a shot put. When we look at the graph, it looks like it's starting about 5. And if you look at the y-intercept is 5.5. Okay? Then it's going up in the air and then heading back down. And looking at the graph, it goes about as high as around 15 feet, somewhere around there, and then it's going to hit the ground. If you notice on the x-axis, it's counting by 5 and it's going past 30. That gives us an idea of how to make our window. So I'm going to show you how to make a window in the graphing calculator. So to make a window, first let's plug in our equation, and then we'll make our window. When we plug our equation in, it is negative 0.0241 x squared plus x plus 5.5. And then you notice when we graph, we don't see the whole thing. So you change the window. So I'm going to go to window. I'm going to make my x min lower because we're not dealing with negative. So I'm going to put -5 just so I can still get a good picture. My x max, I know it has to be above 30. Think about how far someone could throw a shot put. I'm going to say, I'll say 60. And I'll count by 5. And then my y min, again, we're dealing with the ground, which is at 0, so I'll just go a little bit less just to get a good picture. And I'll say my height was around 20, and I'll count by 5s as well. I want to go above 15, because just in case it is above 15, and hit graph. So there we go. We have a good picture. And again, you could have adjusted it differently and still gotten a pretty good picture. So we said our x min and our y min, and I'm always going to make my x min and y min -5 for all of these problems, just to get a good window. The x max we said was 60, and we counted by 5. So we said the y max was 20, and we also counted by 5. Because again, I could tell it was 60 because 30 is almost at the halfway point where the vertex is, so go a little bit further. So, how long was the throw? Well, this means you need to find when the ball hits the ground, which is the x-intercept, right? The x-axis, it said, is representing distance. So this is the distance the shot put went. The y-axis is representing the height, how high the shot put went. So to figure out how long the throw was, we need to find the x-intercept. Okay. So to do this in your graphing calculator, we are going to use that 0 tool. So we're going to hit second, trace, 2. As I'm approaching that x-intercept, I'm approaching it from above, so it's going to be above. Hit enter. Go below, hit enter, and hit enter again. And roughly about 46.41 feet. Is the length of the shot. That's how far they threw it. When does the shot put reach the maximum height? Well, this means we need to find our maximum. Go back to the graphing calculator. use that trace tool. Second, trace, maximum. We're finding the maximum height, so we're going to go to maximum. Go a little bit to the left. Go all the way back. A little bit left to where you think the maximum is. Go a little bit to the right of where you think the maximum is. Hit enter. And then, yes, hit enter. So we're going to enter 3 times after each movement. So here's the turning point. It's roughly 20.75 and 15.873. So the shot put reaches its maximum height when at 20.75 feet horizontally. Again, when you're asked when does it reach the maximum height, you're always looking at the x value of the vertex, or turning point. When you're asking what is the maximum height, that's the y value. And the y value is 15.873, or 15.87. Keep it consistent. What is the height of the shot put when it is 15.5 feet away from the thrower? So here, this is where you can use that value tool. We can do second, trace, value, and type in 15.5. And that gives us about 15.23, or 21. It's about 15.21 feet. 100 is 2 decimal places. So 15.2. So there's example 2. If we take a look at example 3, it says Amy tossed the ball in the air in such a way that the path of the ball was modeled by the equation negative x squared plus 6x. In the equation, y represents the height of the ball in feet, and x is the time in seconds. We need to figure out a window. And again, I always use -5 as my x min and my y min. We have to figure out our x max. So Amy tossed the ball in the air, and we have to figure out how high it went. So think, how high can you throw a ball in the air? Probably not super high. So we'll just say 50 feet. So that's how high it can go. So I'm going to say around 50 is my y max, and I'll count by 5 or 10. Our x max, when you toss it in the air, think about how far it falls. Probably not that far from where you toss. You're not tossing it out, you're tossing it up. So I'm just going to keep it at 10 and count by ones. And let's see. So we're going to go to our calculator. We're going to clear out what's there, and we're going to type in the new one, which is negative x squared plus negative x squared plus 6x. Again, I might have guessed this window, and it's totally wrong. So we're going to go to window and adjust. Keep that -5. I'm going to make that 10 and count by ones. Keep that -5. I'm going to go 50 and count by tens. And let's see. Oh, I made that way too big. So we can still get a good picture. If you want a better picture, I'm going to make my y max a much smaller. I'm going to make it more like maybe 30. There we go. Could probably even make it smaller. Looks like the highest it goes is like 10. You could have kept it at 30. Let's say 20. And we'll count by 5. Again, that original picture was fine. I'm just trying to get an even better one. So you just have to play around with your window so you get a good picture. There we go. Okay. So it says at what time x is the ball at its highest point. So again, in this scenario, if we go back to the directions, it's saying that x is time and y is height. Okay, x is always time, y is always height. So it wants to know when it reaches its highest point, and B is asking what is the highest point. So we want to find the maximum here. So we're going to go second, trace, maximum. Go a little bit to the left, a little bit to the right, and then guess. And that's roughly 3,9. So that means, again, x is time, y is height. So for A, it takes 3 seconds for it to reach its maximum height, and it reaches a max height of 9 feet. X value is the time, the y value is the max height. And then C says determine when the ball reaches the ground. That means we need to find the x-intercept. So we go second, trace, 0, enter. And again, as I'm approaching the x-intercept, I'm approaching it from above, so I'm going to start above. And I can tell I'm above because my y value is positive. So enter. Go below. I know I'm below because my y value is negative. Hit enter, and just hit enter again. And it looks like it hits the ground after 6 seconds. And there you go. There's example 3.